All right, we're continuing with lines. Now, what they're going to ask us today is to find an equation for a line that is parallel to a line they gave us. So we don't want the same line. We want one that's parallel to it. Now, I have some activities that I may have given you, but what we need to see, what I usually have you do is make a couple lines, and you start to see that what makes them, so suppose I had this line. This line and the line they gave us here are parallel. And how do I know that? It's the slope. If the slope is exactly the same, that means while you're making the line, you're going up and over exactly the same. So this one's going up 2 over 1, up 2 over 1. Well, so is this one. Well, that's going to create railroad tracks. They're never going to touch, and they're going to be parallel to each other. So if I want to find the equation for a line, now I don't know it's this, I was just giving an example. I want one parallel to the line they've given me. Okay, well, what that means is I'm going to take the slope because I know it's the same as the line I want. Now I don't want this line anymore. I just wanted to find the slope because they're the same slope. Now, I've got a point and a slope. I know how to do this. This is exactly what we were doing now in our last video. I'm putting in the y and the x. Solving for the b. Now don't forget, I need the whole equation, so go back and put the b in there. Okay, same idea. Pause if you want to try on your own. They're parallel. So I'm just going to take, this is not the line I want, but I do want his slope. I'm going to take the slope. I've got a point. Now let's put the point in. I've got my x and my y. Okay, so the line I want is this. Put it back in there. Okay, now let's find a perpendicular line. All right, so again, hopefully I gave you an activity, but what you're going to find in an activity is that two lines are perpendicular. If one's going up at, like here's this one, it's going up at 2 up, 1 over, 2 up, 1 over. Well, to make them hit each other, which is like, it makes perfect 90-degree angles here. I'm not much of a geometry person, but all 4 angles here are 90. Well, what you've got to be doing is you've got to be building it upside down and with the opposite sign. So what I mean is, if I've got a slope of 2, the perpendicular line will be upside down from that. It'll be 1/2. It needs to build in the opposite fashion, and it needs to build in the opposite direction. So a perpendicular line, you take the slope, you turn it upside down, called the reciprocal, and you put a negatives in front of it. So other than that, it's the same thing. So I've got my slope here. It's 1/2. Now I don't want this line anymore. I was just using it to steal his slope to know that it's perpendicular. We want a perpendicular to that one. Now I've got a slope and a point. So as you might imagine, we're doing exactly the same thing now. All we needed, the extra step was just the slope. So I've got a 1 for my y. Okay, so come over here, -1/2 times -2. It's like over 1. Cross reduced, you see this is all going to become 1. Okay, this one's a little different. So if I send a 1 to the other side, a -1, b is going to be 0. So my equation is just -1/2 x. There's no b to add because it's 0, so I can leave it off of there. Okay, try one of these. Now, a perpendicular slope is upside down, so that's like 3 over 1, so I've got 1 over 3. It was positive. Now it's negative. Okay, same game now. I don't want this one anymore. I was just doing it to get the perpendicular slope. Let's put in our coordinates. I've got my x and my y. Okay, now we got to deal with some fractions here. So I'm going to add 4/3 to both sides. It's a fraction, but it's still a number. So let's come over here. I'm going to turn 2 into 2/1 and add it to 4/3. Now I need these to have a common denominator, so I need this to be a 3. So I can't just change it to 3 without multiplying. I multiplied the bottom by 3, I got to do it to the top, so I get 6. Okay, now the denominators are the same. Just add the top, so I get 10/3. So I get 10/3 equals b. Put your equation back together. Okay, another one here. Do you see that my perpendicular slope now is going to be -2? I'm going to turn it upside down, give it the opposite sign. Now I don't need that anymore. I'm going to do what I've been doing. Give me the final line. Okay, so this line we just made is perpendicular to the one they gave us. It would hit in that crisscross that makes the perfect intersection with 90-degree corners everywhere. Okay, now I like this one. I was like, is this the same thing? No, this is not. Now look at this. We know that 1, 2, 3, 4, 5, we have a vertical line. That's what an x-line is, a vertical line. And we want one that's perpendicular. Does it make sense to you that a perpendicular line is going to be a horizontal line? Well, horizontal lines are just y-lines. So we're going to do a trick that we did in the last video. If I'm perpendicular to this line, all I need is oh, I did that wrong. All I need is that point. Let me say this again. Okay, so take you through here again. I've got a vertical line at x is 5. I need one that's perpendicular. Well, perpendicular lines are horizontal lines. Those are y lines. All I need is the y coordinate. So I don't have any math to do. It's more of a logic puzzle. A horizontal line's a y line. I take the y coordinate and I'm done. Okay, I bet you can see where this is going. Perpendicular line would be a y line. I just need the y coordinate. Make sense? Okay, now they're just going to go the other way around. I'm starting with a y line, so what's perpendicular to that must be an x line. So all I need is an x line that is using the x coordinate. Ooh. Oh, that tricked me, but that is right. So the x coordinate here is the -4. Okay, we want a perpendicular line to y equals 1. Well, that's an x line. All I need is the x coordinate. And then they just keep doing it over and over. Perpendicular to a y line is an x line. I just need the x coordinate. And I've got it. Okay, that is parallel and perpendicular lines and how to find their equations.